event on behalf of the European Commission, the Research Executive Agency. Sofia, the floor is yours. Thank you so much.
Yes, good morning, everybody. I'm delighted to be here today on behalf of the European Research Executive Agency and welcome you all to this webinar. As Andrea said, I'm Sofia Pachini. I am project advisor in the unit of biodiversity, circular economy and environment in the Research Executive Agency. Today in this webinar, we have the opportunity to learn more about the new publication of the cluster that showcases the 32 case studies, which are the core focus of the 7 projects within this cluster. This achievement is the result of remarkable hard work and collaboration between these projects with the support of the European Commission services. So congratulations to the entire cluster for the hard dedication and commitment. This cluster has been also very active during the preparation of the European Union Water Resilience Strategy that was very recently published. As the cluster is now expanding with the addition of new projects, the cluster has considerable potential to contribute to the implementation of the strategy and its actions related to addressing the zero pollution challenge. We will be learning more about this later today too. At REA, we remain committed to encouraging projects to collaborate, what we call in our jargon clustering. This publication serves as a very good example of this type of successful collaboration. Our extensive experience with monitoring projects shows significant benefits from these collaborative efforts. Our goal within the agency is to witness increasingly more projects forming clusters like this, leading to increased impact and successful utilization of project results. So without further ado, and because the agenda is quite packed today, I hand over the floor to the next presenter, and I hope you all find this session both informative and engaging. Thank you very much.
Many thanks, Sofia. Thanks for your kind words. I mean, on the work carried out by the cluster. We are Water Europe, being the coordinator of the cluster. We're really keen and honored. I mean, to support the water resilience strategy and the other strategies that can support addressing the challenges of the water and water sectors now and in the future. So now I would like to give the floor to Bertrand Valette from the DG RTD, European Commission, for the keynote of this webinar. Thank you.
Thank you, Andrea. Thank you all. My name is Bertrand Valette. I'm a policy officer in the DG RTD in the unit Water, Seas and Ocean for the research and innovation. And I wanted first to thank the ZeroPollution4Water cluster for having invited me to do this keynote speech during the European Green Week event. It's a good opportunity for me to remind a bit the policy context which underline the 2 projects at the origin of the cluster. And because we published the water resilience strategy very recently, I will also look at how the project can contribute and the outcome are contributing to this strategy. So in 2022, when the topics addressing the prevention of groundwater contamination and the protection of its quality and securing drinking water quality by protecting water sources against pollution were published, the European Commission just presented the EU Action Plan towards a zero pollution for air, water and soil in the context of the Green Deal. And by the way, the Green Deal is still relevant today, so we continue to implement this piece of legislation. And this plan refers to the implementation of the revised Drinking Water Directive as for January 2023, which introduced quite some innovative aspects, including new standards, new contaminants to be monitored and regulated, and the implementation of the risk-based approach to drinking water. Beyond the limits that were strengthened to better protect the human health, like for pesticide, for example, there were new contaminants added, and it is now considering PFAS or trialomethane, which are one PFAS and emerging contaminants, trialomethane, a disinfection byproduct, which are addressed by the cluster in the different projects. And obviously monitoring is very good, but preventing is even better, and the prevention cannot be done without a good understanding of the risks that are occurring in your system. And this is the purpose of the risk-based approach to water safety that was developed in the Drinking Water Directive, that can encompass risk assessment and risk management for three main elements: the catchment area, so what gives the quality of your water resource, each supply system, which include the abstraction, the treatment, the storage, and the distribution of the water to the consumer, and then the inner domestic distribution system, so the distribution system inside the buildings. So these measures were at the heart of the two topics leading to the cluster. And the Zero Pollution Action Plan was also mentioning the aim of reducing pollution from key substances in surface and groundwater. So this translated with the revision of the Groundwater Directive and the Environmental Quality Standard Directive. These two pieces of legislation are still under trilogue, so there is no final decision, but we can have a look to what the proposal was proposing. And mainly it looked, or the main relevance with the cluster is that they look at the watch list, so the principle of the watch list that was present already for surface water was proposed to be applied to groundwater. And it's crucial because it allows to follow the evolution of the quality of the groundwater bodies. And with the new substances like PFAS and pesticides and pharmaceuticals, these were added as substances to be regulated by the Environmental Quality Standards regulation and directive and the Groundwater Directive. There is also the addition of one specific concept, which is the environmental quality standards for river basin specific pollutants. So this is basically what can be followed specifically in the catchment area, and this encompass a wide list of contaminants. So this proposal reinforce obviously the protection of human health and the environment, but it also requires some innovative solution to be able to follow these concentrations in the different water bodies with reliable method. We cannot only think to the new pollutants, as we still have challenges to monitor and assess the risk with some more conventional contaminants like nutrients that are accumulating in some water bodies. The review of the legislation needs to be accompanied with monitoring and management methods to be able to address these new pollution. And the two topics that we propose and for which the cluster projects were granted, the objective was to anticipate these future needs with the proper implementation of the water legislation. So we addressed in these topics the mitigation of specific pollutants by exploring the development of removal technologies for PFAS and pharmaceuticals. We also focused on nitrate and pesticides from agricultural and urban sources, and considering the monitoring of pollution. Related to that, we asked to advance sensor-based monitoring system for real-time groundwater quality tracking, considering scalable and cost-effective solutions. And finally, it was also required to explore preventing and mitigating strategies to protect groundwater against pollution. So this is why today's webinar is so important hopefully for the audience, because it will give you an update on these innovative solutions and set of tools that are developed by the cluster. And the beauty of the cluster is that it's not only answering to the challenges of the past, but it also contributes to the future objective of the European Commission As you know, we published on the 4th of June the water resilience strategy, so I will a bit explain what it is in this strategy. The vision is to have EU water resilient and secure by 2050, and it proposed to a set of measures to achieve three main objectives: restoring and protecting the water cycle, building a water smart EU economy, and ensuring a clean and affordable water for sanitation for all. And to achieve those, there is 5 enablers addressing the governance and implementation, investments and infrastructure, digitalization, innovation and industry, and security. And to go a bit more into the detail, for the first objective, so we need to better act on land to restore the water cycle and embrace a source-to-sea approach, address also pollution like nutrients and PFAS. For building a water smart economy, we need to put in place the water efficiency first principle, to support also water reuse, allow to reduce leakages, and also because we want to increase in digitalization, we obviously need to find solutions for having data centers that are more water performant, so to increase their performance with certain measures. And for the last objective, that ensuring clean and sanitation for all, we need to address water footprint of products, enhance the public awareness on the availability of the resource, and also with better pricing principles, to address water resilience in the built environment, to give back the keys to consumer to make wise choices related to water consumption. So several measures at different levels will be put in place. First, we need to reinforce the governance and transboundary cooperation, and to do so, we will engage with member states in structured dialogues, and also to build a visualization tool so that they can, when they plan, they do special planning, they can do it with the relevant information to do it with protection of water resources. Then we need to provide the necessary funding to overcome the funding gap in water infrastructure. And for this, the EIB will launch a program and an advisory facility with 15 billion over 25-27 to help investing wisely in the water infrastructure in Europe. We need to unlock the private investments. For this, we will also establish a water resilient investment accelerator to implement 20 pilot innovative cases for natural water retention and water efficiency. Digitalization, as I said, is an important step. And we need to have an action plan for digitalization in the water sector to promote smart metering and facilitate also the use of water dedicated products of Copernicus. So really with this, we will have a better evaluation of the availability and the quality of the water in the EU territory. We also more on our side, on the GRTD side, we will develop a water resilience research and innovation strategy that will help to guide research and innovation funding in water for the future, so a long-term planning. And we also, with the GRC, dedicate Water Academy to upscale skills. Finally, we need to develop the tools to better protect water infrastructure against malicious attacks and to get them prepared against the effect of climate change like drought and floods. If you look at all these measures, it is clear that there are actions that are linked to the outcomes of the work of the cluster. And I hope that this little review of policies will allow you to even better understand how crucial these results are and how you can uptake them and implement them for your facility maybe. So thank you very much, and I wish you a nice webinar.
Thank you very much, Bertrand. Really insightful inputs, and also for the additional motivation for the cluster and the project that are involved in the cluster and the future ones, because as Sophia mentioned before, the cluster is expanding. And there's a really important, I mean, beyond the motivation is also the matter that we are able to achieve results, and these results can really contribute to support the achievement of the European Union strategies, not only the water resilience strategy, which now is really our driver, but also the other strategies, and I mean the Green Deal and whatever can support really the conservation of our ecosystems, having in mind that water, it is really basic for the survival of our society. So that's the reason for which we all advocate for achieving a water smart society and economy at the same time. So many thanks. Thank you so much, Bertrand, for your contribution and insights. And now, I mean, we start having after the keynote, the launch, I mean, this one of the core issues of this webinar, the launch of the application of the Zero Pollution for the cluster, for which really, I mean, I'm very much thankful to all of us, and particularly to Margaret Remet-Rieper for the Tech Innovation organization, for the Safe Crew sister project of the cluster that really committed, I mean, to build with the other colleagues this great publication. And many thanks to the European Commission Research Executive Agency for having published it and gave a visibility under the umbrella of the European Commission. Now, I mean, we start, and before giving the floor to Margaret for the launch of the publication of the Zero Pollution for the cluster, I will just remind, you see also in the chat, that I really ask the speakers to keep that time. At the same time, questions are welcome, and from the audience, you are really very much welcome to write your question in the chat, and I will try our best to respond to all the questions that are coming from the public. What to say more? Once again, thank you, Margaret and other colleagues for this great effort, and the floor is yours. I mean, to provide the insight from the inventory of these 32 case studies in drinking groundwater. Thank you.
Yes, thank you for inviting me to present the overview of the inventory of 32 case studies in drinking water and groundwater. And thank you to Sophia, Andrea, and Bertrand for setting the scene. Let me see that it works. Yes, it works. I now have the challenge to present you 150 pages and 32 case studies, and want to highlight some key insights from these case studies. As Andrea and Bertrand already said, this is a launch of our publication, and I also want to thank the European Commission Research and Executive Agency for supporting us and giving us a floor for this publication. Our case study sites, we are 7 projects and we have 32 case study sites. The 32 case study sites cover wide geography, as you can see from this slide. We cover 12 European countries plus the Ukraine. And in addition, we have case study sites in Latin America and in Africa. What can be highlighted is that the majority of the case studies is situated around the Mediterranean Sea, which already highlights how much the countries around the Mediterranean Sea already experience the adverse impact of the climate change on the groundwater and drinking water supplies. We've got 14 drinking water case studies and 18 groundwater case studies. So I said that. And what's really important is to highlight the context dependency and the need for adaptation of all the solutions and policies. Bertrand already introduced the general objective of the projects. So we have 3 groundwater-related projects. They aim at providing solutions which enable the prevention of groundwater pollution. And each of the 3 projects has a different focus in this huge topic. On the other hand, we have 4 projects which are dealing with securing of the drinking water quality. Again, they set different focus with H2O for all, into DBP and Safe Crew, concentrating on the need for disinfection and the negative potential of DBP formation and how you can prevent this. And the 4th one, to drink, opens a wider range of solutions to a wider range of pollutants, including PFAS and metals, etc. I'm starting with the groundwater projects, and we all know already the key challenges related to climate change. We experience water scarcity and droughts, and they increase the concentration of pollutants also in the groundwater. We experience declining groundwater levels and overexploited aquifers, intensive rainfalls, flash floods, will contribute or lead to transfer of pollutants into the groundwater. The groundwater projects deal with salt intrusion, with the diffuse pollution from agriculture, with contaminants of emerging concern, and they want to address the gaps in understanding accumulated stresses and impact in interconnected water bodies. Their solutions can be sorted into 4 categories. The first category deals with the monitoring of groundwater pollution with hard sensors. Even if the monitoring with hard sensors is already state of the art, new pollutants as well as new challenges ask for improvements. There is a wealth of different hard sensor solutions, and I can only pick one here. So if we look into the second bullet point here, for example, the NINFA project and its case study in Spain is aiming to develop a multisensory optic fiber device for measuring groundwater pollution, salinity, nitrates, etc. There are much more developments in hard sensors, and just see my slides as appetizers to dive into the publication yourself. Hard sensors usually pick one event at a time, and to really answer the risk-based approach of the new legislations and to answer the frequent extreme weather events, we need soft sensors and modeling to provide real-time monitoring and prediction models. Again, the case studies produce a real wealth of different models. For example, the case study number 7 in Portugal of the Mark to Protect project deals how the ecosystem services can be modeled to provide groundwater monitoring and solutions. Also, the NINFA project is producing a groundwater knowledge observatory, which covers all the insights from the 8 case studies of NINFA. Nothing is solved if we only monitor the pollution. So the project also developed treatment solutions. They focus on nature-based solutions. Let me just pick up the fourth bullet point, upwater, and it's plus bioelectric chemical wetlands. Wetlands are a major treatment solution, nature-based solution. To conclude with the groundwater-related case study treatment, I may highlight a couple of novel technologies developed. For example, the case studies dive into improved nano and ultrafiltration, into reverse osmosis, into adsorption or membrane-based processes, or into microbial degradation. This is a very brief insight into the wealth of case study solutions from the groundwater perspective, and I'm now switching to the drinking water projects. Again, we experience climate change related impacts on the deterioration of the drinking water quality. This relates the source as well as the distribution network. We experience, especially the surface water related drinking water supply systems, experience high seasonal variations already now, which enhances the complexity of the source water pollution. We expect increased natural organic matter due to rising temperatures and extreme weather events, and we expect increased growth of bacteria. This may all lead to higher disinfection, and higher disinfection may lead to disinfection byproducts. We do not yet know how DBP precursors like natural organic matter interact with the disinfectants, and how materials, for example, in the pipes and the relining of the pipes, interact with the disinfectants. And this is one of the challenges the 4 projects aim to solve. Also, the monitoring of the concentration of disinfection byproducts along the network is difficult, and there is a lack of risk assessment technologies, as well as a lack of technologies to remove disinfection byproducts from water. These are the challenges. As I mentioned before, to drink, in addition, deals with a wider range of emerging pollutants, where we also still experience a lack of technologies to remove them. The system is more or less the same. And on the basic level, we deal with novel hard sensors to monitor the drinking water pollutants. Some examples are the spectroscopic methods as developed by H2O4All, or continuous flow cytometry, or passive samplers for microbial monitoring as developed in SafeCrew. And to drink has a wide array of hard sensors detecting ions, metals, bacteria, etc. We also need real-time monitoring in the drinking water supply system. This shall be achieved by the development of soft sensors and modeling. One challenge is the intelligent placement of sensing infrastructure, which is modeled by H2O4All, or the short-term forecasting of turbidity with predictive models for algal blooms, to name just some examples. treatment technologies, we will have some deep dive into treatment technologies in the later presentations. We offer a lot of options. For example, to take up Bertrand's mentioning the catchments. Into DBP in Ireland develops treatment technologies which deal with a catchment-based source processes to remove DBP precursors with novel adsorption materials with conductive, with electroconductive membranes. Into DBP develops a new technology, the MITO 3X pilot plant, etc. If we talk about drinking water supply systems, we need to think in a systematic and management way, and we need to, for projects, develop treatment interventions. For example, optimization of disinfection operating parameters, or of optimization of relining materials, upgrade of water treatment tanks, etc. These are the solutions. We also aim at promoting the replication, and for groundwater, and we see a high replication potential. For example, the managed aquifer recharge solutions of MATO project are needed for many sites with similar pollution challenges. And the case studies, the wealth of case studies, will enable regions to tailor their groundwater management approaches to their local conditions. Also, we identified replication potential for the drinking water case studies. For example, PFAS real-time sensors can address increasing concerns of the legislative framework. Decision support tools and management guidance allows the drinking water utilities to deal with uncertainties. So, and there is also the replication potential for the community engagement models developed in the projects. To close close the circle towards Bertrand's introduction, we also see policy implications of our case studies. Groundwater solutions will address the restoring and protecting of the water cycle, and just address the water resilience strategy. And with our drinking water case studies, we want to aim at the revisions of the Drinking Water Directive and the watch lists, and improve disinfection strategies. To conclude, these case studies provide a large portfolio of novel monitoring and treatment technologies, including nature-based solutions. The developed soft sensors and modeling will enable the development of early warning and risk assessment approaches. And with this publication, we invite experts to dig into the wells of the knowledge of the case studies and compare the options for deployment of novel evidence-based solutions. Also, one of our conclusions is that communication campaigns and living labs can contribute to societal acceptance and facilitate the widespread adoption of innovative solutions and behaviors. This was a very quick ride through 150 pages. We can only invite you to look into the publication. And again, I would like to thank the Research and Executive Agency and the Commission that we had the possibility to publish the publication. Thank you. and I'm open for questions.
Thank you, Margaret. Thank you so much. I don't know if you have questions in the chat or from the other speakers and panelists. Otherwise, we can postpone, the questions, to the final session, since we are a bit behind the schedule. So we can go ahead, and I would like to ask Daniela Melman to take the floor and starting, the session on bringing technologies to market uptake, which is quite important at this point of time, since we have the case studies, we have solutions that are being tested, and of course that destiny should be to enter into that deployment. So it means to support them to outreach the market. So Daniela, please, from H2 4All project, sister project, take the floor. You're very welcome to start this panel session. Thank you.
Thank you, Andrea, and thank you, Margaret, for giving us an overview of all those pages and hard work. Now, opening this session on bringing technology to market uptake, we really get into the nitty-gritty and the details of each technology. I would like to give you a couple words of introduction on this working group. So I've been leading this working group for the past 2 years, and this working group called Research and Innovation to Impact. And it has been quite a challenge to find realistic objectives for this working group, and to bring together experts from all the 7 projects to discuss which technologies, which case studies we're going to pick to take as a case to further develop. So we are very happy to be here and to present. This is a great opportunity for our working group to give a chance to all the projects to showcase one of the technologies that they're going to present today. I would like to also briefly tell you about the objective of the working groups. You have heard now a brief overview of the 32 case studies, and the objective of this working group was to select few case studies and to check what are the challenges to take them to up market, what are the challenges and what are the investment gaps that are needed to further develop and to take the technology to a higher TRL level. So we had to go through, for the past 2 years, we had to go through the 32 case studies and to look at their objectives, to look at the TRL, and to rank the case studies, and then finally to select those case studies that are more advanced, that the projects are able to share and to talk about what would be the next stage, certainly after these projects are about to end. So the key point was to try to bridge the gap, the investment gaps, and to see what are the key steps to take it to the next level. We have produced a report that outlines all the challenges and the objectives and the assessment of and the ranking of the case studies, and that has been published last year. And this year, we have working towards another report, which will be a more specific report looking at recommendations on what can be done in terms of taking the technologies to the next level. And we're hoping to publish this in September. In the next coming months, we will we'll have a draft, and hopefully in September we will have a final version. So Domenico, please, I ask you to start sharing the screen while I'm giving these brief introductions. I would like to also to thank Paolo Roccaro and Florencia Gomez Garcia for really assisting the working group in providing the analysis for the case studies. And I have the pleasure now to moderate these sessions with 7 projects, and with each presenter have 7 minutes, followed by 2 minutes for questioning, for you for the audience to ask questions in the chat. So please, Domenico from Into DPP project, the floor is yours.
Thank you very much, Daniela. Hopefully you can hear me okay.
Yes.
Yeah, so I'm trying to introduce with this brief presentation a technology platform. And I'm Domenico Santoro, and I'm Senior Advisor with Aquasoil. This technology is part of Into the BP project. Metox is a platform that allows to improve both precursor removal and oxidation of byproducts. And therefore, in a typical drinking water plant, can be either applied to pre-treatment stage or post-treatment stage, depending if you are attacking precursors or products, oxidation products. It was actually born as a wastewater tertiary treatment technology where the problems are similar. You have to coagulate effluent organic matter in that case, and now we are extending to NOM and the typical drinking water pollutant. In terms of targets, if you want to achieve both NOM management and oxidation or prevention of oxidation of DBP formation, we set for ourselves certain target. So if applied to pre-treatment, we would like to see more than 50% of NOM removed. If we attack the oxidation of formed byproduct, we would like to see more than 80% of DBP reduction. And then there is another application about production of monochloramine as a side stream solution, because the way in one of our case study, monochloramine are formed is through natural turbulence in the channel or in the network, and that's a mixing limited approach leading to production of byproducts as well. So we would like to produce a chloramine stock that is greater than 3000 ppm, and it's high quality in terms of absence of dichloro and trichloramines. When it comes to the challenge, we have to actually consider that different point in the plant requires different optimization strategy. For example, if we are looking at precursor optimization, those processes currently employed are typically mixing limited, while oxidation of formed DBP is typically diffusion limited. So we wanted to take Metox to an optimization point where we can attack both aspects, and I'll explain briefly in the future slide how do we do that. Also, we would like to help adoption of small to medium plants, and those are typically budget and space constrained. So typical ozonation system is, for example, we look at optimizing ozonation, not easily can be retrofitted in every plant because of those consideration on capex and space. Also, advanced process control, and the previous speaker was mentioning fluoroabsorbance. Indeed, that is a novel way we are developing to essentially associate to the novel technology also better control. So rather than a conventional approach, we would like to intensify the process to the point that we can almost use a no contact time, playing with pressure and mixing. And the way we do that is through this patented system by Aquasoil, which consists in its core in a pumping series, where the first pump increases the pressure, and now you can have a better solubility and better mass transfer, and the second provides very high mixing under a very high G gradient or velocity gradient. So again, more to come. So again, as I said, Metox is not novel in general. It was applied to wastewater. It is applied to wastewater, and there are several distinctive features, but the most important one, as I said, is the possibility of using high pressure, 2 to 6 bar, and high mixing. Also, I should mention it's in full scale for wastewater reuse already. So it starts with a decent TRL already, small footprint and low capex, so accessible to several municipalities. And again, with at the end of this project, we hope to have an advanced process control based on fluorescence. Before we could understand the first principle and optimize, several modeling studies took place. This is an example of CFD applied to ozone dissolution, where we changed the speed of the impeller, and this is a bit of the schematic of the two pumping series, and this is the location where the reagents are applied. And you see that the mixing as expected in the pump is really superior relative to other mixing strategy, and the hydroxy radical yield is really high and uniformly distributed in the pump. So that's also an element of efficiency. Into the BP specifically, as I said, one of the application is chloramine formation. So we adapted the technology to produce an oxidant in this case, so monochloramine, using sodium hydroxide and sodium hypochlorite, ammonium hydroxide and sodium hypochlorite, and putting a relevant sensor of mono and dichloramine in absorbance mode in this case, and pH, and we challenge the system to different testing point, and as you can see, the sensor were able to pick all the operating condition. And top right, you have a bit of a surface in a 2D plot where you can see we could identify the ratio of the reagent, which is the red part top right, where you have monochloramine at high yield. So essentially, long story short, in this case, we have an optimization strategy and also a control strategy for this application. And then NOM removal is the one requiring a bit more integrated approach, because not only we have the METOX system, you see osmolysis. You can imagine how a classical ozone system would have been. This is almost 1/10 of the footprint or so. But in this application, we had to put, of course, filtration and other downstream typical processes to mimic the key section of the drinking water plant. So this is the third pilot that will be ready soon and piloted in Cyprus and Barcelona. So what's missing in terms of non-technical aspect? Well, certainly we have to now finish strong into the BP, so we would like to collect as much data as possible and have a strong pilot to convert into case study. This data hopefully will feed a strengthening of IP in general, both on the control, on the technology, and the other ancillary aspect. Then, of course, we would like to now explore new collaboration strategy with the leading supplier, because this is not something that a small entity or even a consortium of entity can tackle alone. To enter then a phase 2, which is almost post into the BP as an early commercialization and starting to attack niche market where probably the competition is less, and then moving into product variants, and then maybe innovative go-to-market approach with service-based model, to finally enter even further downstream, a further phase of scaling a global expansion. From let's say a technology perspective, of course, we are still not at TRL 9 yet, so it would be nice to have support in terms of productization, which is not, prototype anymore, and then of course find a way to de-risk the adoption of the end user, because that's going to be probably another barrier, and eventually some support on the strategic business planning with all the necessary sub-chapters that such a document entails. So next step and conclusion, as I said, I would like to acknowledge into the BP, without which it would not be possible to expand METOX into drinking water. We expect highly productive case study in the next 12 months. And finally, we would like to use them for techno-economical analysis and documentation of case study and the IP enhancement. I think that's pretty much my last slide. So productization is key. Go-to-market strategy is going to be super important at the end of this into the BP initiative, and then accelerating the launch for late 2026 or early 2027 in drinking water. And with that, I hope I was within my time, and I would like to thank you, everybody. I'm happy to take questions, if any. Thank you very much.
Thank you, Domenico. A little bit longer, so please, the next ones, just keep your time. I have a quick question for you on while we checking the chat. The audience welcome to ask questions. I have a question about the DBP. Have you made any, because we have so many of them, and we know through H2O4All, some of the work that we've done is really to look at the ranking of the DBPs and the families of DBPs. When you say you were in the, I think it was in the second slides about the reducing DBPs, have you had any work done on which DBPs or which families? Are these the usual suspects or new ones? Can you tell us a little bit about that?
Yeah, I mean, this is an aspect that ICRA is really focusing. I think there are both the regulated and unregulated DBP list that they are going to track, as well as some untargeted DBP approach with untargeted screening technique like Orbitrap and similar. The question more specifically should be addressed to ICRA and their scientists there, but that's kind of the high-level answer I have.
Thank you. Thank you. We have a question from Matthias. If you can, if all the speakers please open the chat, please, because I also keep the time via the chat. I send you personal messages on the minutes that are left. So please, all the speakers, open your chat so we can follow my time. There's a question: if NOM removal is mentioned, is there more oxidation of NOM instead of removal?
Yeah, thanks for the question. I think it's a little bit of both and depends on the case study as well, and the location in which you put it in the plant. The technology allows the integration of coagulant and oxidants, so it's a fine-tuning approach here between coagulation and removal versus oxidation. This is indeed the initial screening that is going to take place in Cyprus, where the idea is to test different combination of removal versus oxidation strategies, and results are hopefully going to be available in the next few months. But it's both, the short answer.
Excellent. Thank you very much. Thank you, Domenico. The next speaker, Dirk from Project to Drink, will explain our next technologies. Thank you very much. And I remind you again, speakers, please open your chat so I can communicate with you on the time. Thank you.
Thank you. Thank you for inviting me for this session. I'm going to introduce you to a design support tool of flexible drinking water treatment plants. And first, a little bit of context. So climate change and pollution ask for resilient and flexible drinking water treatment plants. And to face these challenges, we need a knowledge base and also decision support, because different aspects are playing a role, like water, but also energy costs, etc., for system designers and managers in utilities. So to this aim, within the To Drink project, we have developed a web application that facilitates the user in designing resilient and flexible drinking water treatment plants. So in the previous slide, I've introduced you to the main challenge and aim of coming up with such a design support tool. And more specifically, we have focused on the different treatment technologies which already exist and are applicable for drinking water treatment plants, but also other components like uncertainties associated to the capacity needed for drinking water production, or the treatment efficiency. And next to that, also try to come up or propose different design alternatives which the user can choose from. And the typical user is well, the system designer or a water manager at water utilities. So to come up with such a solution, the design of a drinking water treatment plant, we need, like said, a knowledge base, or in this case, we have put all kind of characteristics of treatment technologies in a database. And to come up with a preliminary design, we have included in those characteristics not only technology characteristics, but also cost parameters and parameters related to CO2 footprint. So going a little bit more into detail, the user is facilitated by the design choices by an automated decision tree procedure. So we have translated this into our knowledge base of the decision support tool. And throughout the workflow, the user has the option to select from a range of technologies, but also which parameters are most important for the user. Next to the characteristics of these technologies, also, like said, uncertainty parameters are defined and characterized, which relate to the complexity of the treatment plant or the robustness or the flexibility, and also to the environmental impact here measured as a CO2 footprint. At the end, the user is presented by a table of all the advantages and disadvantages per technology and uncertainties associated by having this drinking water treatment plant proposal. We have developed this tool in Django, and furthermore, we are going to make it available to the public by making it open source. So that's one part of the roadmap. Of course, we're not there yet, so there's further work on development of the tool. Within the project, there will be an evaluation and a validation, and of course, it will be tested by the different partners within the project. And by making it open source, it will also be available to other water utilities, which can also, of course, test the tool and commit changes. So the open source code creates opportunities for further collaboration and integration with other tools already present within water utilities. So this is also my final slide, so I'm happy to answer any questions raised by this presentation. Thank you.
Excellent. Thank you so much. I have a couple of questions, and if anyone else has some questions, please use the chat. You talk about users and so the tool is, and you said it's also open to the public, but is it more for the engineers, operators to use the tool? And also, I would like to ask you, I mean, obviously, to design such a system, I mean, there's so many variables to include. I mean, you talked about the database of treatment technology, but also the type of waste streams that come along, the geography, and so on. Would you include all these variables in this tool? And where is it at this point, and sorry, so many questions, and what level you are, and is there a pilot, and if you could tell us a little bit about that.
Yes, thank you. I think the first question was about the end users. So which type of end user this tool is aimed at? I think predominantly people within water utilities where a new treatment plant is planned and where some guidance is needed. So decision makers within water utilities, for example. So that's I think the main application. The other question I think it was about the evaluation and where the development is of this tool.
Yes, I mean when the design of wastewater treatment plant from experience, I mean, there's so many variables and that needs to be taken. And I'm just wondering how big is this database of is it like a pick and mix and then adjusting the best solution for a specific area, for a specific type of waste stream? That's sort of, is it a one-stop shop for all, or is it more specific?
Yeah, a one-stop shop for all would be ideal, of course, but we're still at the beginning, I would say. So right now we have a support tree for surface water treatment, and we will extend this with groundwater treatment and make it as flexible as possible, of course. There are still some features which can be further automated. So let's say you have a decision design tree that's quite straightforward to set up, but then you need to translate this into, let's say, database tables. And this can be further improved, and we would like to have some ideas and collaboration with other partners. So, but this is still to be evaluated and discussed. Like I said, it's still on a pretty low TRL level, but there are lots of opportunities to extend it further for more use cases. Yeah.
Thank you very much. The next speaker, Maria, if you can please upload your presentation. If there are any more questions for Dirk, please use the chat. And Maria from H2O,
Yes.
I will be presenting the central knowledge base, another web-based solution.
I think that I am sharing now.
Yes,
Can you confirm it? Okay.
Yes.
Thank you, Daniela, for the presentation. As Daniela said, I'm Maria del Mar Blanes from Iris Technology Solutions. We are an engineering company based in Barcelona, specialized in developing advanced monitoring systems and integrating cutting-edge technologies and driving digitalization to the industry. As Daniela said, I will present one of the technologies developing H2For All project that is called Central Knowledge Base. That is a digital platform that supports better management of the drinking water safety. Before going into the technical part, let me give you some context of the tool. The Central Knowledge Base is designed to support everyone, if I can say like that, involving the management of urban drinking water. The goal of the tool is to connect these different actors in a common digital space and encourage the collaboration of them. First, I can present the main users of that platform. First, we have the regulators, that are the public authorities who make sure drinking water, drinking water, yes, is safe and compliant with the quality standards. Then the operators, which are the water supply companies that are responsible for the delivering clean water to the public. Next, we have the citizens, that if I can call, with your permission, I can call them like the end users of the water, of the drinking water. So the aim of the platform is to raise awareness about water quality, responsible consumption, and so on. So it's a way to communicate directly with the citizens. And finally, the researchers, who are essential stakeholder in the supply chain of drinking water. Because they bring knowledge about emerging pollutions like the DBPs, then better detection methods and more efficient purification technologies. A key strength of the project of H2 4All is that all these groups are actively represented in the projects, either as a partner or as engaged stakeholders. So thanks to all of them, because we receive a lot of feedback for the development of that platform. Then the main goal of the central knowledge base, I think that I already mentioned it, but is to enable collaboration among all these actors using the FAIR approach, that is making data findable, accessible, interoperable, and reusable. We address key challenges such as the lack of centralized and georeference data on DBPs, then also limited access to real-time monitoring. So the operators told us that sometimes they don't have the real-time monitoring accessibility. And then the disconnect between all the stakeholders. It's true that they are in connection, but not in a same platform or in a safe environment, in the same environment. So here I am presenting the main functionalities of the main structure of the platform. The platform offers two main interfaces. One is the public area that includes educational content and interactive data visualization to raise awareness, specifically among the citizens. I will show you later some screenshots, so you can see how this look. Then we have also a private area that is designed for registered users like regulators, operators, and researchers. This part provides a kind of tool to upload data, manage the system, monitoring real-time quality data, and so on. Something that I want to highlight is that this platform uses a modular design and includes data collection from smart sensors developed in the project, but is able to be, we designed the platform with the aim to include more sensors. Right now, we have just the receiving data from the sensor installed in the project, but the platform can support more sensors. The connections to more sensors. Then we are analyzing the data, because also there are some functionalities like alerts, geovisualization, and so on. Also, another thing that I want to highlight is that the platform allows the integration, or the platform can work with two kinds of data. One is data coming from the sensors that are so, for example, we are receiving concentrations of DBPs, pH, water quality parameters, but also the platforms allow the upload of information like documents, links, and so on. So as I mentioned it, here you have some screens. I select just 3. The platform has different sections, but I select the most important, if I can say like that, sections. The first, I don't know if you can see my cursor. No?
Yes,
well,
we can. We can
okay.
see it.
Okay, so the first one, that is this part, is the public section. Here we have an interactive map that is displaying information about the region. So this is a kind, we are processing the data from the sensors in that region, and we are showing an average, a year average, but it's not just showing the information, like the parameters, the value of the parameters. If not, we are also giving like information useful for the citizens. So here the regulators or the operators can adjust the message that they want give to the citizens, so they can alert about the DVPs, or they can highlight the impact of that values and so on. So the citizen is not just receiving information in terms of data or numerical data, if not, they are also having some interpretations. And then we have the other part, is a kind of repository, a public repository. Here only the authorized users can download the documents, but the content is available for everyone that wants to consult. And then we have the other two parts or screenshots that are sections, the private section. This one is the private repository where internal data can be shared between the relevant stakeholders in each region. And then here, the final one, we have the real-time dashboard. Here we are displaying in a continuous way coming from the sensor installed in the water supply infrastructures. So in this case, as I mentioned, the sensors are the ones they developed and deployed by the project. So here we are monitoring the concentration of DVPs and normal parameters regarding the quality water. Then well, the first pilot of the central knowledge base is currently running in Coimbra, so we are testing it in Coimbra because are the pilot region of the project. So we are using and validating the sensors and receiving feedback from the real users, because as I mentioned in the project, we are lucky to have the real users involved in the project. Then, as I mentioned, the platform is designed to grow and scale up. And we are working to make it compatible with Fireware and IPCHEMA, that are two EU-supported platforms. So we think that doing that, it could be make future integration at national and European level much easier. Sorry. So that is our goal. Well, to make this tool fully operational across Europe, I think that there's still some investment to be done or needed. One is, for example, extend or expand the number of sensors deployed, because as I mentioned, for the moment we have we are just testing in Coimbra, so the idea is to exploit it in another regions. And that's all, because the others are more general. And finally, we think that the central knowledge base, well, we think the project partners, we think that this platform has great potential to become a reference platform for DVPs and quality and water quality initiatives. Our idea, the idea of the project is promoting it, because we also think that has potential to support future policies, developments on DVPs, because as I mentioned at the beginning, it's a platform where all the stakeholders are there. So you can receive feedback for all of them and you can communicate with them. So that's all for my side. Thank you very much for your attention.
Thank you. Thank you, Maria. While I ask you some questions and see if someone has some questions, can the next speakers upload the presentation? Evgeny, if you can upload the presentation. So I have a couple of questions, Maria, and others I'll put them in the chat. How confident? If you can,
I need you to stop your presentation so that I can start mine.
Maria, yes, you can. If you can please close the presentation so Evgeny can upload the next presentation. How confident are you in terms of utilities companies inserting data and really making it a working tool? And on top of these questions, how about security of data that is in the tool and ownership of data? What's your thought about that?
Yeah, regarding the first question, it's true that the water utilities, maybe they are not the stakeholders, the main stakeholder to upload data. So I think that in the public, sorry, Daniela, are you referring for the public section or for the internal one? For the internal one, I think that they have to do it because it's a way to communicate with the regulators. So I think that I know that the operators has to update the regulators with regular reports. So this platform allows to do that in a easy way because they are receiving data from the sensor and then they can share with the regulators. But then if you are referring for the updating of the information in the public section, it's true that maybe the operators are not the main users that will do that function. So maybe the researchers will publish more information about the researchers and so on.
I see. Okay, thank you. And another question. I mean, actually, I have a lot of questions, but I'll write in the chat. Who do you think ultimately would be the best owner of this tool? For make it really user-friendly, usable, that
I think, the strategy is, because I think that one of the users that has that could have more I don't know how to say, but could use more this platform are the operators, but it's true that the owners, I think that the end will be the regulators, because it is a way to connect all your region. So if there will be a final owner, I think that the best one is the regulators or a public authority that manage the region. So they all the stakeholder of the region map it and connect it through the platform. But it's true that our strategy is to push the operators to start using it, so they will force the regulators to acquire the platform.
Yes, I think it will require a lot of talking to the different regulators and utilities, and to see how it can be a tool that can be useful for everybody. So, well, that's thank you very much for presenting the central knowledge base. The next speaker, Evgeny from Upwater. The floor is yours. One more. Please open your private chat, because I'm keeping the time with the sending messages on private chat, because we want to give fair time for all the speakers. So the floor is yours. Please go ahead. Thank you.
Thank you, Daniela. So my name is Evgeny Bulatov, and I will present you ceramic passive samplers for analysis of organic contaminants in water. The problem of organic contamination in water stems from our developed organic industry that counts with tens and even hundreds of thousands of organic compounds that are very useful for us, but in the end of their life cycle, they usually end up in the environment and very often in water. And all of a sudden, they transform into contaminants that are potentially dangerous to environmental and human health. The problem with them is that due to their structural diversity and low concentration in water, their analysis is always based in laboratory and is rather costly. On the other hand, we have constantly growing legislative pressure to control this type of contamination due to new European regulations coming up. And there is a built-in pressure between this need to control this contamination and its price. Somebody will have to pay for this. And to understand our proposal, how to release this pressure, we need to understand, first of all, that any chemical analysis in laboratory starts with taking a water sample. And in the scale of taking water samples for analysis, there are extremes such as grab sampling, which is the most primitive and simple approach, which provides a very limited data. And on the other hand, there is an active sampling, which is advanced and programmable, but expensive, and the machine requires energy and cannot be installed in all of the locations. So in the between of the spectrum, we find passive samplers. And in our opinion, passive sampling is the only feasible approach to permit low-cost, wide-scale monitoring of organic contamination in water. So what is the technology that we are working on in the UpWater project is a ceramic passive sampler. I show you the real scale in my hand. So it's a rather little device of the scale, the size of a real battery, normal battery, that consists of a ceramic cylinder inside of which we place adsorbent. And this device is placed into water for the duration of typically 1 month. During the time that it spends in water, it accumulates the organic contaminants that are present in water. And after that, after 1 month, it is retrieved from water and taken to laboratory for conventional analysis using chromatographic methods. And what it provides us is average concentrations of a wide spectrum of contaminants over this duration that it has been in water, so typically 1 month. What the result of it is that we can achieve continuous monitoring of a wide spectrum of contaminants with a single monthly measurement, with a single monthly sampling event. The technology that we developed allows us to produce passive samplers of different size and porosity, and also it allows to change the adsorbent to adjust to the needs of particular task or particular client. The passive samplers that we are working with they are prototypes that have been verified in numerous relevant and working conditions. So we consider the technology readiness level at the level of 6 to 7. And at this point, we are taking this further. We are trying to take it to the market to offer it to the real industry. And the challenges that we are facing in this process, they can be grouped in several groups. One of them is the product definition. Particularly, that is both challenge and opportunity, that there are various environments where passive samplers can be used, and we have to come up with clear instructions how to use them. We should maybe diversify the range of products. And also there is a regulatory acceptance that we have to handle. On the other hand, there is a market challenges, such as in some places we have a well-developed market, but we also have competition present. And in the other places, we don't have so well-developed market, so we have to convince our potential customers that this is a useful technology. And finally, we have challenges associated with the startup creation, such as completion of our team, which is closely tied with the funding challenges, which is in its own turn tied with the sales that we need to initiate. Briefly touching upon the business model for commercialization of this technology, is going to be a very lean model in the beginning, outsourcing everything possible, including intellectual property from the institution, the production of all of the components from our production partners, and all the analytical services from our partner laboratories, so that the spin-out can focus particularly on sales of the passive samplers, interacting with the clients, consultancy, and offering the sampling and monitoring services. If we take a look at the roadmap, we find ourselves in the red mark, which is right in the middle, right before the key milestone of commercialization, which is creation of the spin-out company. So we can see that there has been a lot of work done behind it, which involves academic development, minimal viable product development, and also we have now achieved some industrialization partnerships, and also we have several certain early adopters that work with us currently. And in the future, we have the idea of introducing this product to the market, growing the client base, so that when the industrial product comes out and we are ready to sell it in large quantities, we can start growing the company towards the exit, towards properly functioning commercial unit. A little bit touching upon financing and investment needs. Since in the early stage, the company is going to be very small, we are looking into private funding, and we are looking into small individual scale funding in the beginning to just support the startup of the company and survive until we get the first sales to organically support and grow our company. As we get the industrial product ready, we can start looking for investment to expand our team, expand the product offering of our company, up to the point where we can convert our passive samplers that would be growing in sales to the vehicle of selling the analytical services, so that we could internalize analytical laboratory into the company. And that would require a significant amount of investment. And with this, I would like to summarize that currently we have CPS technology well developed to the stage when it is ready to enter the market. And our next steps are going to be well-defined product. We need to scale it up to be able to sell and to ensure its reproducibility. and of course the tasks related to business development. And on the right side of the screen, you can see our latest dynamic in regard of KTH model of business development. With this, I'm finishing. Thank you very much for your attention. And if you have any questions, I will be glad to answer.
Thank you, Evgeny. While there is one question in the chat. Will the material be recycled? Can you see the chat? How elution from the ceramics is processed?
I can.
Yes, and in the meantime, Peter, if you can upload your presentation.
Thank you. Relevant questions. Thank you, Matthias. First thing, well, yes, ceramic is a very sustainable, it's a recyclable material, so that is a positive. Yes, we can recycle ceramics, and generally it is a low-cost device and low-cost material. The other question that it just gone. All right, there it is. How regarding the elution of the contaminants from the passive samplers once it is a laboratory, we try to adjust our product to such a way that any laboratory that is currently using solid phase extraction can just take it from here and introduce it into its day-to-day routine. So once the passive sampler is opened, the adsorbent can be placed into the SPE cartridge, and from there on the standard SPE extraction. If that answers the question.
Thank you.
Thank you. Just to let you know a little bit of advertisement. Evgeny is going to have present his work at length in 40 minutes webinar or something like that in September. And please watch the space on the cluster website. We're going to advertise the work that Evgeny has presented, and he will explain to us a little bit more details on the process and how the business plan and the business model and how we can take this technology to market. So watch the space and follow us on the cluster website for the webinar that Evgeny will lead in September. The next presentation from Peter from Safe Crew. Please, the floor is yours. Thank you.
Good morning, everybody. Good morning, Daniela and all the others. Thank you very much for giving us the time and the space to show you some toxicity testing. Can you hear and see me? Yes. Okay.
Yes,
so
please.
We would like to talk about non-animal and effect-based testing for disinfection bioproducts in the Safe Crew project. So if you look at the Green Deal, then you will see that there's also a strategy, a chemical strategy for safe and sustainability in it. And there's it mentioned that we are looking towards a toxic-free environment. So this shows already and indicates that, of course, also toxicity testing is required. And in this report, it also addresses the cocktail effect. And it mentions also that we should phase out endocrine disruptors. And we definitely believe that also PFAS is also an endocrine disrupting chemical. We are using these effect-based and non-animal methods mentioned also in this report. So this report mentions also that we should focus on human cell-based biocides, such as our Calox panel for general toxicity, endocrine disrupting properties, and POPs such as PFAS. Now, as Evgeny also mentioned already, so it's a complex mixture of thousands of known and unknown CECs in the water. Therefore, it's a major challenge to deliver safe and affordable water services to a growing population. And we are very happy to be a part of the Safe Crew project because here we have many innovations in several EU water treatment sites. And if you look at the latest drinking water directive, then it gives now room to develop risk-based monitoring programs. And therefore, we are very happy to share our technologies for different toxicity pathways, such as cytotoxicity, genotoxicity, oxidative stress, early warning, endocrine disrupting effects, PAHs, and PFAS-like properties for disinfection bioproducts, but also in different kinds of waters. Now, the challenge is at the moment that now it's mentioned in the Drinking Water Directive and in the Urban Water Directive, is to use these risk monitoring methods, but it's not very described which kind of methods and how to use them. So in the just finished European project promises, we defined that different bioassays in the CEN Working Agreement 18,201. And now it's our job to get it also more international and known. So thank you very much for sharing this with us, that you're also interested in that CEN document. So there have been, in the last 20 years, many of these ABMS NUMs have been developed, and now they are just ready to be used in water testing. Only a few of them have been, via ISO standardization, validated. For example, for estrogens and for dioxin-like compounds. So now we are busy, of course, also to expand this also to PFAS and other DBPs. And at the same time, because this is non-animal testing, it's also used, of course, in OECD framework for endocrine disrupting testing. So there are also a few of those tests. But of course, we need more international mandatory testing requirements for usage of EBMs in water. Now, the technology is already since 30 years established. The first test was the dioxin testing. About what we are doing, so it's high throughput hard testing. We receive 1 liter of water, we extract it, and then we put it on our cells. We have robots who are doing that, for example, a robot for seeding, this human cell-based. And then we have a robot, the Hamilton Star Lab, which is then making different dilutions, so you can make a concentration response curve. And at the final end, you have a luminometer. In our case, of course, we are high throughput out here. So we have this Swiss stacker. This is basically the how we are doing that. And then we have all kind of different test systems, for hormones, for POPs, for CECs, PAHs, DAGs, whatever you call them. So many of them. So for the regarding the market uptake, as I mentioned before, the SEN guideline is one of the first steps, but we need more of those policy briefs and documents to show that and to showcase with these technologies. As we are since more than 20 years established company, of course, we have many international corporations. At the moment, we are very busy with the California State Water Board for the PFAS testing, as well as, of course, there's a new European Horizon call with India. So we are building now several consortia to use this bioassays. And of course, to use this technology in the international scale, you have to talk to the water technology providers. We are in contact with the global water companies. And of course, the most easy way is you should train them in your in-house, and then they learn the technology and they establish their own laboratories. So we have about 200 licensees all over the world who use our bioassay in all kinds of different applications. And we make every year a biodetector conference, which is next week in Genoa. So if you have time, please come along. It's in Genoa. It's a beautiful city. And of course, we are fully active in the international networks and publications. And at the moment, of course, we hope that more this Dutch success story for toxics testing can be also understood and interested in other countries of the world. The investment is about, if you want to establish such a technology, it's about 60k euro for a laboratory to do that. And usually, just to give you an idea, the reagents material cost is about below 50 euro per Calux per water sample, just to give you a price indication. But of course, the gaps for selected technology, but as I mentioned before, it's of course very important to have international validation and implementation strategies and also the documents for these various NEMs. So we are very happy with Safe Group because here we have a chance with several international case studies where we can show this applicability of toxicity testing for relevant compounds and especially also the complex cocktail where we all have to face from pharmaceutical, from plastics, from DBPs and so on. It's quite a wide range of different kind of toxic chemicals. So we support many international policy agreements, briefs and SEN guidelines. We are involved in international framework and guidelines for use of the NUMs, but we really would support that it's going a little bit faster than at the moment. So we hope that regulators also speed up the implementation of these guidelines. Now my conclusion is the last slide. As I showed before, such effect-based and non-animal method you can use, of course, to prove that your water treatment and your water monitoring is toxic-free. And then you are going more in the direction of a Green Deal or blue water monitoring. It's of course used in many water treatment plants in the world to show that your water is safe. And of course it is safe because, as I mentioned before, it monitors known and unknown complex mixtures of the CECs. And as I also mentioned before, in this bioassay, you can test all kinds of different pollutants, such PFAS, microplastics, DBPs. And of course, for example, in case of PFAS, it covers up to 7,500 PFAS. And it's of course very important if this technology are below the LOQ, then you cover a huge amount of these pollutants. So it's more safer, especially for nasty mixtures of these substances. And I also hope that more and more people realize that there are ISO standards, there are OECD guidelines, there are ECFAM, DBI methods. These methods are already approved, but they're just more on the chemicals, on the chemicals testing approved. But now there's not a big difference if you measure a chemical or a complex mixture in a water with this kind of test systems. And we hope that there's also more notice to the SEN guideline, to the OECD EDC freshwater guidelines, the California and Dutch Blue Water Strategy in a global scale. And now I'm open for your questions.
Thank you, Peter. It seems that very, very much established technology. And how, quick question about the new contaminants and the upgrade of these technologies, and what we always finding out new DBPs, new PFAS, and not regulate, and talking about the not regulated one, and what is the approach for your company to continuously let's say upgrade the technology, and how to find the new the new contaminants?
So this is a very good question, Daniela. So we are looking one part on the chemical part that we just make effect-directed analysis. So we just have, for example, for the PFAS, we use a wax column, which is specific for PFAS, and then you can use the biosounders. But on the other side, we also realize that there are also many toxicity pathways. So we are very, very busy, for example, in case of PFAS, that we know that there are thyroid disruptors, there are obesogens. So we are developing, at the moment, we have 10 different technologies for looking into thyroid-like activity of the PFAS. And also for the obesity, we have developed 3 different test systems. So our way is really to develop new technology and then to show the whole framework of toxicity of such known and unknown chemicals. But on the other side, if you look at a complex mixture, like for example, 1 liter water, and you extract it, and you don't find activity in the bioassay, in a wide range of bioassay, then you have a very safe umbrella. And this is, I think, very important for the Green Deal, for the future, to have a toxic-free environment. So we are very happy, and we are looking forward to use more and apply more in the international scale this technology. But I also have to say, we are always surprised, because we are 30 years on the market, that there's also in Europe, it's only a few countries which are really active with that. So I hope that more people understand. In some countries, that's very urgent. I mean, Netherlands, we are drinking 60% of our water from the rivers. So therefore, we have to have a good monitor here in place.
Thank you. Thank you. While the next person, Christoph, uploads the presentation, I would like to, well, thank you, Peter, and I would ask you, Peter, if you maybe join us in the webinar in September to talk a little bit more about your journey on the market uptake of the technology, because you seems to have so much experience. That new technologies that of the other project could really benefit from learning from your journey, and so this is an invitation to you, Peter, to join us in September and to talk a little bit in more details on the work that you've been done. So that's an invitation. And the next speaker, we have 2 more, Christoph from Mar2 Protect. The floor is yours. Please go ahead. We can see your presentation well.
Okay, thanks, Daniela. Thank you, everyone. Greetings here from the Global South in South Africa. It's really a privilege to speak to you today. And yeah, so I'm presenting one of the technologies from the Mar2 Protect project. And in this case, the goal of the technology is to boost soil health and in the process protect groundwater from nutrient pollution. So just some context. So nutrient pollution is a growing concern globally. I guess most of you are aware of this fact. The main or the principal sources of nutrient pollution is agriculture and sewage. Those are the 2 ones. In surface water or direct application on the surface, and that can then leach into the groundwater and then in the process contaminate groundwater bodies like aquifers. So there's this increasing rate of NPK, for example. These are the main nutrients that we find polluting groundwater. This can also further degrade soils. So one way to improve soil quality or to mitigate this leaching of nutrients into the ground is to improve soil quality. This can be in 2 forms, in the structure of the soil or the biology of the soil. And I'm going to elaborate a bit on that. So and this work is part of the, like I just mentioned, the Mar2 Protect project, where the overarching goal is to protect groundwater reserves. So if we think of soil biology, healthy soils means healthy ecosystems within the soil. This ecosystems that are healthy is a dynamic, creates a dynamic environment where nutrients can, through natural processes, be broken down and made more bioavailable. You can have, in a really ideal situation, literally amino acids available in the soils, and that's really easy for plants to take up. So if you have healthy soils, root growth is stimulated by the plants. That means, and also nutrient availability is boosted and nutrient uptake. And the end result of that is basically less nutrients needed, but also less nutrients that can leach into the ground. And in that process, you can, through having healthy soils, have a protection of groundwater reserves. So in the technology I'm presenting today, it consists of two components. The first component of this technology is functioning to improve the structure of the soil. This is a novel technology that features photocatalytic oxidization, and then in combination with organic sequestering agents that's pumped straight into the irrigation lines, and then through this oxidization process, basically calcium ions are taken into the soil, and this can physically change the soil structure. So it's a chemical intervention that can physically change the soil structure. And this causes much more aeration and and root growth and so on, so boosting soil biology. The second component of the technology is through biostimulants. This is a bit more known by in general by people, that way you can basically feed the microbes. If you feed the microbes, they are better food for the higher levels, trophic levels within the soil ecosystems. So this biostimulant package of this filtering technology includes, on the one side, carbon sources, and on the other side, nitrogen sources. So it's working together for this ideal, like, food for the bugs on the ground, eventually the worms, etc. So this boosts increased nutrient uptake, reduced fertilizer needs, and also crop yields. So I want to just show, we've got one case study that was done in the past growing season in South Africa on this Uvamira wine farm. So there was this different treatment blocks where we had a control, we had only biostimulants, only hume flow, and then the combination of the two. And then they were monitored over time. So just quickly on the results we found. So on the left, you can see, if you look at the graph, on the left, the light blue would be the combined treatment, and this individual treatments, and then on the right would be the control treatment. So the data shows in this crop cycle, the Chardonnay grapes, that there was in fact increased nitrogen uptake by the plants. And then also, if you look at total nitrogen, this is the different nitrogen species. And if you look at the total nitrogen, also there was an increased uptake by the plants. This showing that, in fact, they are healthy, high protein, good plants. There's much more to present, but I just picked out some data here. And then on the right, this is where the proof in the pudding is, where there was actually more than a 10% increased yield in the combined treatment. So much more grapes that were produced from the fir tree treatment. So from a commercial perspective, it's really positive. Some of the challenges in general with these kind of products, you need to do it. It's almost like taking your antibiotics. You got to stick to the program. If you don't stick to the program, it's not going to be as efficient. So it's the same with the farmers. They've got to stick to the program. And sometimes when there's a crisis, something break, or there's a storm or whatever, they abandon it. So that's a challenge, to stick to the program. Consumer trust is a major challenge, because biological farming is not the status quo. You like to blast the fields with the fertilizer. That's more the status quo. So you've got to change. There's got to be a paradigm shift with the farmers and thinking more biological farming. One, on the technical side, to create products that are actually water soluble, these organic products, to get it into the irrigation lines, that was a challenge for the Humford team that produced it. Produce formulations that are cost effective and robust. Okay, we need it not only in Africa, but everywhere. We want to save some money. So just the roadmap for ahead for market uptake exploitation. Filtrate is already available in South Africa and in Namibia. So the next steps would be expansion to other parts of the globe. Then also to gain consumer trust from farmers. That's also a part of the map ahead to promote the technology. And then also one thing that's the human flow itself, which is a capital expense part of the system. There needs to be some buy-in into that, so people are willing to invest in that. So investment needs for the technology, it's pretty far developed already, sitting at TRL 7.8. So there's not necessary investment needed for further development, but there is for global expansion, there's investment needs. So just in conclusion, the Fertile technology represents a promising technology, both from a commercial farming perspective, because it could reduce your input costs and increase your yields, but also for us to save the globe, to protect the groundwater. So it's also making a case there. Some next steps would be to actively increase consumer trust in the farmers, so that they trust and follow the biological farming approach. And then also to continue technology testing, generate scientific data. And this is in the More to Protect project. It's ongoing activities to scientifically prove that the technology actually works. Thank you. That's all for me. And are there any questions?
Thank you, Christoph, for the insight. Please, anyone has questions in the chat, feel free to write now. I have a question about the challenge on the farmers. For you, it's the farmers. For H2FOR is utilities, regulators, and this, let's say, called the social side on involving stakeholders anywhere in the world. It's a real challenge, and that I think we all have in common, because we have all this amazing technology, but really they cannot be used. Like, what is the purpose if they cannot be adopted and taken up? So what is the journey that you learned from the South African experience, that talking to farmers, is there a process, or how do you, is it the focus groups? Do you actually go one-on-one with the farmers? How do you approach them, and how can you really gain their confidence, and what can you do differently in the States, for example? Because obviously different culture have an effect on how you need to proceed in different ways. I mean, so what's your key learning from the South African experience?
Yeah, I think educating the farmers, so they actually, understand the technology, understand the real benefits. At the end, that's a major thing, a key. And I think in the context of the More to Protect project, we've really had it's a really nice project, because it's not only protecting groundwater through technology, but also through changing human behavior. So living labs is a key part of the project, and that creates a platform, for this, to make people understand and to realize it. So I think engagement, and also in the technology itself, the distributors of the technology and future distributors can also play a big role there. But yeah, community interacting with the stakeholders is absolutely a key thing. But I think, like I say, in this new project, the living labs is a really a useful approach to do that. I hope that answers your question.
Yes, it does. And mentioning living lab is key. And this is some part of what we will want to add in our recommendation for taking the technology to market, because we tend to think investment, and we tend to think about these hardcore processes, that business model and so on. But the let's say the soft side on living labs and engagement with it's a very, very good point that we need to add and remember that that's key for success adoption of the technology. Thank you so much. The next and last speaker is Martin from NINFA project. Please go ahead and upload your presentation. Thank you.
Okay, I hope it's visible. Thank you, Daniela. You can hear me? Yes?
Yes.
So thank you very much. I'm presenting indeed the last project, NINFA project, and the project aims to develop cost-effective groundwater monitoring strategies, pollution prevention and abatement technologies, and also focuses on early warning systems. And today I would like to tell a little bit more about one of the pilot locations and how we are doing the monitoring. So the location is in the southeast of Spain. And at this location, we focus primarily on seawater intrusion into the groundwater aquifer, eutrophication, and over-exploitation. So the objective is to apply innovative monitoring of this groundwater. And what is especially important here is to look at the saltwater intrusion. So near to the wells of the groundwater, you can have the seawater intruding and going towards inland, and you would like to know when this saltwater is well, approaching your wells in this case. So it would be nice to monitor that directly in the well. And for that, we do different types of monitoring. So we developed a fiber optic sensor, which means an optic fiber, like you also have for your internet, for instance, telecommunication. We can adapt this fiber, and we have to adapt it in such a way that we can monitor connectivity. I'll tell a little bit more about how we do that. And we can actually monitor that in the depth direction. So at various levels in depth, we can monitor the conductivity. And in addition to that, we tried to apply some commercial sensors to do some data acquisition. For instance, a nitrate sensor, conductivity temperature sensor, pH redox sensors, etc. And the pilot will take place in September 2025. So the current challenges that we have are more of practical nature. So the robustness of the sensors, as you will see later, the optical fiber-based sensor has a very thin region, which needs to be protected and is possibly fragile. We also have some impact of unknowns. So there might be unknown elements for the optical absorption that we also apply in one of the sensors, which might render the data less valuable. So it really, we really need to do a case study to understand these different aspects. And of course, also the durability and maintenance needs to be become clear from these tests. So looking at the technology, the optical fiber-based sensor works as follows. It works with fiber break ratings. I'm not going to go much in detail on how this is working, but you can change a little bit of the properties of this this fiber. And what we do is we have 3 of these different fiber break ratings, and between the second and the third, we make a thin region. We stretch the fiber basically while heating, and then the fiber gets thinner. And then light that is propagating through the fiber is coupled out into the groundwater in this case, and can interact with groundwater. And then the region where it gets thicker again, light is coupled back, and when there is a change in the conductivity, we can see a shift in wavelength. So we can see a shift of color. So in this way, we can make multiple of those structures along the fiber, and we can measure at several depths. And then we also developed this system where we can measure temperature, pH, conductivity, ORP, and dissolved oxygen, and also some optical sensors that measure absorption or transmission at several wavelengths. So 235 nanometers to 80 nanometers, 400, 461, 520, 641. And with those, we can actually, for instance, measure nitrate and some other components. And then also we've developed this UV-vis fluorescence sensor. And all that is then connected through a SIM card to internet, and data can be automatically uploaded to cloud service. We also tested this in the sister project, H2O4All, for monitoring the water quality parameters and also giving input to let's say the soft sensors that are being developed within this project to determine DBPs. And we've installed this system in summer last year, and the same system will be installed in the NINFA project. And a company called Aquacolor Sensors is actually currently selling this whole system. So it's currently on the market, you can buy it. Except for the fluorescent sensor, this is still a prototype, but the others are available. So if you then look at the roadmap for the market uptake, then the first with the optical fiber, we are still at validation in the lab. So we know that the system works. We can measure the conductivity, but it has to be further optimized for putting into the pilot location. And then we need to validate this technology. So it's still early stage technology. Then for the optical sensors that measure transmission and also the whole complete set that already is on the market, but still needs to be validated in the field. So especially for the groundwater measurements, we still need to identify what information we can extract from these sensors and how they can serve, for instance, for soft sensing and the models that are being developed within the infra project. So the investments, well, primarily for the first one, the fiber brick rating, the technology needs to be further optimized. So this really is early stage funds for further tech development. And then the sensor set really requires mostly the market validation. And then the sales can be upskilled. So conclusions, we did some successful laboratory tests. The sensor sets were already installed at the pilot location at H4All, but needs to be installed at the new pilot for groundwater monitoring. Market introduction already happened for tech number 2 by Aquacolor sensors, but as said, it requires further validation. So the future next steps is to study. The study should focus more on the further development of the fiber-based sensor and also the successful deployment of the prototype sensing systems at the location in Spain. So thank you for inviting me and having me, and I'm available for questions.
Thank you, Martin. Then we should say that you're sitting on both of the projects, and so that's very interesting.
Primarily in H4All, I have to say, but with the development of the fiber, I'm also involved. So this is indeed, I have 2 feet in 2 projects. Yeah.
It's great because I think you're sharing the knowledge, exchanging of the knowledge from both. So thank you very much for clarifying that and your work in H4All. Does anyone have any questions? I think there is one comment in the chat. If you can have a look, Martin, from Peter.
I cannot see the chat at the moment.
I'll read it. Bioassays can measure the toxic effect of the mother compounds and their transformation product. So if the bioassay is below the LOQ at the NG/L levels, you have good indications that mother compounds, transformation product, and metabolisms are toxic free.
I guess
just
for the
the
other
answer to the
speakers.
point above.
Ah, okay. Sorry. Okay, I didn't realize. It would be good in the chat if you can write it to who is the question. So, but thank
No,
you.
this is not a question. This is the comment to Rui C. Martens, to the comment
Right.
before.
Yes. Okay. So, are there any comments and questions for Martin? We're running a little bit late, but it was very important to having all the projects presenting the technology and the work. So thank you so much for putting the presentation and sticking to those number of slides. This is the end of session 4, and I'll give the floor back to Andrea for the panel discussion. Thank you all.
Thank you so much, Daniela. Thank you to all the speakers from the session 4, bringing technology to market uptake. Now we enter into quite a strong debate, which is about turning research into action. And I invite in this virtual panel the sister projects of Water4All, of the ZeroPollution4Water cluster. And so I invite the Master Protector with Ana Belén Pereiro, Nympha with Ainhoa Godes, Upwater with Enric Vázquez Suñé, H2For All with Rui Martins and Luisa Duarez, into DBP, Domenico Santoro, Safe Crew, Matthias Ernst, and To Drink with Dirk Vrias. So welcome into this panel. we have a number of questions that around which we can start discussing. The first question, which is for everybody, for every panelist today here, it is for sure we have obstacles. I mean, to turn the project results into real world market-ready solutions. And then this is a question for all of you. What kind of support would you need the most? I mean, both from the public authorities or the public side or for the private actors? So what is the kind of support that you need? I mean, really to turn, the project results into market-ready solutions, or to fill the gap or the breach, from lab to market. Luisa, please.
Yes, I was thinking on this during the presentations. I think the most important factor is the connection with an utility company, really. Because if you have the connection with these sites or utility companies that can test the technologies or the approaches, you are in a much better position to go forward with the technologies and understand if they are applicable or just or only just in the lab. It is the most important thing is to see if it is feasible. So I think it's one of the most important factors.
Thank you, Luisa. So now, I don't see the order of the question, but I can start from what I have in the video after you. So it's Matthias.
Yeah, thank you. Yeah, I think also looking back to the presentations from Peter, it is very important to consider the transfer into technical rules and guidelines, especially if we consider these biotoxicity tests. So it's really important to include discussions of technical boards of the utility networks all over Europe, national-wide, but all over Europe. I think this is very important. And I also got the information. We have another product, which is an online THM sensor, which is almost completely developed. It's able to discriminate between the different THMs. And I think one thing that was raised by our partners is confidence to apply such innovations for testing in the private sector. That would be also very important.
Many thanks, Matthias. Now is the time of Ana Pereiro.
Thank you, Andrea. In our case, Mark2Protect is one of the groundwater projects, and our approach to the prevention of the groundwater contamination from the climate and global change is a new generation of managed aquifer research. And we have 7 different demo sites, and in all demo sites we have living labs and different society engagement activities in order to have a clear, from the beginning, a clear opinion of the all-important stakeholders, whatever utilities, policymakers, NGOs, or other associations related to our technologies, the opinion from the beginning of the development of technologies in order to increase the performance and the result and the impact of our results. But the problem in the aquifer, in the managed aquifer research, is this strategy is common in and applied in Europe in different countries, and there are a lot of examples, but don't have a European regulation. Okay, is the application is carried out taking into account the specific problem and the specific pollutants and the specific context of the local region. Then I think that at a European level, and this managed aquifer recharge depend of a lot of different regulation, wastewater regulation, drinking water, reuse, irrigation, reuse water. Then it's very complex, okay, the policy framework related with this strategy. Then I think that at a European level, we need to design a very good strategy to reuse the water and to apply the aquifer recharge with a very good quality and quantity water, but we need a regulation at a European level, in my opinion. Is our more challenge, okay? Because there are a lot of samples, but for specific problems, not for a general context, okay? Taking into account all problems at European level, in my opinion.
Thank you, Anna. So, I mean, there is, a strong component, in policy development should be taken into account. Now is the time of Domenico for Into DBP.
Sure. Yeah, so from my perspective, more on the, our core technology, if you will, support is missing perhaps when it comes to development more than research, right? I mean, we always say R&D, but it's R&D. So the R, more or less, there are a lot of instruments that you can tap in. When it comes to the D, the product development, I think there isn't as much. And, if we stop at prototype level, even if we reach TRL 8, it's not enough for a utility to take that final risk, right? They want to buy a product, not a prototype. So I think, SMEs probably need support in the D, which is, to me, product development. And then the utilities have to be helped in taking risk. Because, if I put myself into the shoes of a utility, why I do want to take risk with an emerging technology where, there is no reference in full scale, components may not be as tested as somebody else with 30 years of installation and so on. So I think the two areas is really some instrument is missing for SME to really invest in product development. And unfortunately, that's not a minor investment because it could be in the $1 million or euro range, right? To go from a TRL 8 to TRL 9 or product, it's a lot of money. And then the utility, they have to be incentivized to take risk. And only when you reach 2, 3 full scale, you get the attention of the big water company, right? Because they see this coming in full scale, not only, let's say, into, research dimension that it's not really of interest of those big giants in the water space. And unfortunately, in the water space, we are dealing with 2, 3 big conglomerates. We are not dealing with a very diverse ecosystem of players. So again, to stimulate the appetite of those final adopters, whether it's a technology provider at large scale or utility, we need to bridge this somehow. So that's my thought there.
Thank you, Domingos. So I understand that it's also a matter of risk sharing between different actors. I mean, the implementers, the problem owners, the solution providers, and I guess also investors that might be interested in investing on a sector which ROI is still, I mean, an issue. So it's not so much attractive. Now we have Ainhoa Gaudes.
Yes,
Please, Ainhoa.
Well, many things have been said. Yeah, I totally agree with Domenico and also with the previous speakers. We need to involve and engage water utilities, and also because our projects have advisory boards and in which we can reflect or adopt their needs and adapt our technologies to their needs. I think this dialogue is basic. Also, I think that something that helps a lot to develop those products is sometimes to have a transdisciplinary team in the project with different networks and different points of view, and to get involved in meetings. Sometimes it's a bit challenging, but also if you succeed, you have a vision, a wider vision of what the market and the society needs. So I think that maybe for the public sector, we have good connection. Maybe for the private sector, we would need more efforts to have more companies or to support the SMEs participating in this kind of projects to upgrade their products and to get into the market more easily with with innovation markets. But I guess that this is something that we could do also from the public administrations to foster this kind of interactions between the European projects, to highlight our products like in the Water Europe innovation market. So I think this is the good way to help to improve this adoption of our innovations.
Thank you. I know. So I also understood that one suggestion could be also increasing the collaboration between large companies and small medium enterprises. Whereas the latter are quite dynamic and can produce, I mean, striking products that can be supported in the say outreach, I mean, to the market also by large companies that might involve in terms of credibility and financial support up to the final users, utilities. Which, I mean, could be an interesting journey because it might motivate also utilities, I mean, to take more risk if they see that larger company are involved in the process. Now is the time of Eric. Please take the floor.
Thank you, Andrea. Thank you, everybody, for attending, and thank you for inviting me in order to comment these questions. I'm already agree with the previous speakers, but I have to focus on some main barriers that we have to face. And these barriers include three main aspects, in my opinion, that are regulatory inertia, because in many emerging pollutants and monitoring tools are often not yet covered by legislation. This has to be put it in the floor. But also we have to face limited awareness and risk perception of groundwater issues among decision makers and the public, because the public is not aware of what is the risk that involve the pollution of groundwater. And also the third one is the financial gaps to bridge the space between pilot scale and full scale applications. This is a very important thing, because if we don't have any more tools to develop or to upscale the solutions, this is impossible to show it and to prove the efficiency. So to overcome these barriers, we need at least
four things that include the private and the public sectors. That are the first one is a policy alignment and flexibility from public authorities to integrate innovative tools into water quality monitoring and permitting frameworks. To support for technology, validation and standardization. We have seen in this previous presentation different approximation for similar solutions for similar problems, but we have to make a more standardization effort in this sense. To include the private sector engagement in co-developing and testing market-oriented services, for example, through public and private partnerships or spin-offs, and also having in mind that their objective is to make business, not research, and also to provide targeted funding schemes for scaling up the prototypes. So that's the first barrier, the last barrier that I have mentioning. So this kind of funding schemes include live projects, ACA, or similar platforms for this funding. This is our opinion.
Thank you, Eric. Thank you so much. I see that there is a land from Rui Martins, H2 for all.
Thank you all for your comments and for the presentations. Indeed, I think that one major driving force to implement the new technologies that we are developing is the public. So I think that the true public engagement and awareness regarding the water quality and the problems related with the water will be for sure a pressure for policy changing, which will for sure lead to the implementation of the technologies that we are proposing here and their scale up. So in that sense, for example, platforms like the Central Knowledge Base that is being developed in H2O for all is an important tool to provide transparent information regarding the water quality, regarding the policy status, regarding the technologies that are available for water quality protection. It's very important to be developed. So I think here the role of the regulators that somehow should promote the use of these kind of platforms that the water utilities provide information worldwide about the water quality status is very important, so that we can feed the public with reliable information about the water quality and the prevention measures that we can do to improve it.
Many thanks, Roy. Looking also, that was a comment by Bertrand Vallet from the GITD about the reflection of Domenico about the matter. The European Commission also proposed at the end of May the startup and scale up strategy, which it looks to be designed to help small medium enterprises to really overcome the risks in the investment. So I think that also this could be a part of our debate. At least you find the link to this initiative in the chat that could help projects and the audience and other stakeholders of the ZeroPollution4 cluster and related projects and initiatives to go deeper into this issue, which in my opinion is extremely important because a risk is high, is always high, and it is understandable that many stakeholders might not be happy to take the risk of innovation, but at the same time, we really need to work in order that whatever we develop in terms of research innovation from the European funded projects can enjoy a pathway towards the market uptake. And for this, it's from Water Europe side, because we support this with our implementation program, which also includes the utilization of water and living labs as testing and scaling up ecosystems, and of course also the Water Europe marketplace, where ready to market product can be uploaded and made them visible, I mean, to the proper owners. I don't know if there is any other contribution from other projects to the question, to this debate. If not, I would like, I mean, to thank you all for your contribution, and now we pass, I mean, virtually to the Mentimeter, the floor to the audience, and to, of course, I mean, to you as well. We have, I mean, a short Mentimeter which we want to gather as much as possible ideas and insight from whoever is participating into this event. So let's join the Mentimeter.
I hope you can see my screen.
We can see the screen for sure.
Okay, I try to put it in
Go to present. Yes, right. But we don't see it yet. But anyhow,
you don't see it?
no, I mean, we see only one contribution for now. It seems that your screen is...
Maybe they are arriving.
No, I mean, okay.
Wait. I try to...
Can you put the link in the chat, please?
Yeah, I'll put the link in the chat. Okay, now it was good, huh? Just go to present.
Okay.
We cannot see yet, I mean, in the presentation mode, even though we see some of the words coming up in the cloud.
I have it on presentation mode on my laptop, but you can see it on presentation mode?
No, we don't. I don't know the other colleagues, but I don't. It is updated, but it is not in presentation mode. But it doesn't matter. Let's go ahead. So it seems that from the cloud, the public awareness represents one of the most important points, which is also very much understandable, because we just discussed yesterday with some colleagues in stakeholders of Water Europe about the matter that we need really to work on water literacy, which is not, I mean, up to the point that we would see. And I think that we can go to the next question. Now, I mean, the question is, which type of case study results would be most valuable for your work or region? But we cannot see it, so I mean, on your screen, Anis.
Sorry, I have a problem. I don't know why. I stop it and I will... Can you see it now? Wait.
No.
And now?
Now we can see. Let's see, I mean, if
Can you see it right?
no, we can see the slide, but we don't see the updates.
I don't understand.
Okay, now for a while it was, now we can see it. Maybe there is a bit of delay between the presentation and the screen sharing.
I don't know. It says that my screen sharing is on pause, but I don't know how change it. So I hope you can still see screen.
Doesn't matter. Now it seems that policy recommendation and regulatory insights represent the most popular choice. The second one is nature-based solutions, water treatment. The third one is data-driven decision support tools and novel monitoring technologies and risk communication strategies as the last one. We can go to the next question, please. Now, rank the following actions. Now this is full screen mode, that's how it works. Rank the following action in terms of the importance to scale up innovation for water pollution control. So you are requested to rank importance.
It's working now.
Yeah. Okay, thank you. Seems that's still, stronger regulation alignment across countries. So, the regulatory issues and increased funding for piloting and upscaling. So there's a matter of working on the EU political agenda and working on the capacity of the water sector to have access to the investments and funds for piloting and upscaling. Is the second one. So it seems that the stronger regulatory alignment remains the most important point for our audience and speakers. Then improve collaboration between research and industry, open data sharing and interoperability. And the last but not least is a citizen engagement and communication. I think that we can go to the next.
Can you see it? I've changed the slide.
Yeah, we can see it now. This is an open question. So making reference again, to this great 32 case studies, how the results of this case study can help shaping an EU or national water policy. So what could be their contribution? To the EU and the national political agenda on the legislation frameworks of the water sector. Can you scroll a bit? So once again, I mean, we can see that the regulatory issue and let's say the legislation plays an important role, but at the same time also we see that there are points about the final users contributed to undertaking the risk. That's something that's been debated. Include all EU members in regulatory boards. It is also interesting, the last one, guide towards a better understanding of which solutions are suitable and the kind of efforts and cost involved, and also saw something on top of the contributions. If you can scroll up, Anaïs, for a while, there was a bit more. Okay, it's interesting also. The 32 case studies can be a clear picture of what the action should be taken in terms of working on the legislation and engage the public, which I personally think, it's important to engage, the citizens and users to better understand what is the efforts to have water available, the right quality, quantity, and the right time, and an affordable price, for all. And as well, increase dissemination, social media, and sharing results to support policy changing. So I think that we have quite a wide scenario of ideas and contribution from this last slides of the Mentimeter. We put together all these inputs, and of course we'll make available along with the presentation of today. I think that we can close the Mentimeter. We are a bit behind the schedule, and now I don't know if there is any other question that we might answer now. Otherwise, there will be opportunity for answering also to the public at a later stage. Well, that's fine. So, we are at the session 7, which is about the closing remarks. So, I would like to invite Eike Thijssen for opening the closing remarks and provide us a summary of the key takeaways of today and what is important, call to action. Eike, the floor is yours. Thank you so much.
Okay, thank you very much. Yeah, I'll just sum up today what we've been talking about. So looking into the case study inventory, we have a total of 32 case studies from 18 countries within our 7 groundwater and drinking water projects. And really what we see is that we have a very large and diverse portfolio of novel monitoring and treatment solutions. And the inventory, the document as such, gives an excellent knowledge base to provide evidence-based guidance. And this is on a range of topics. This is on these treatment technologies. This is on the monitoring and how to do effective monitoring, how to do effective source apportionment, how to deploy in detail our low-cost technologies, which are also including nature-based solutions, very importantly, and last but not least, the policymaking and the implementation. And the cluster actively works towards highlighting the replication potential for these technologies in other contexts. Some projects are actually directly testing the replication potential, but of course this needs consideration of the different contexts of the regions. If we look at the different technologies showcased, well, we've seen a broad range of different novel technologies that are close to market uptake. The main hurdles that remain are really quite dependent on the technologies that we consider. But I think there's some things that go again. I've made here a compilation of what I could extract from the different presentations. I think that some of the main things that really are incoming for some of the technologies is a lacking legislation. This can be on the monitoring of some of the CECs. This is a struggle for the ceramic passive samplers, for example, but it's also the monitoring of complex mixtures of chemicals in certain water bodies, such as groundwater that's not used for drinking water. And this creates little market. So if we don't have the regulation in place, then we also don't have the incentive for people to buy our products. There's also insufficient implementation of some of the existing policies that we have. This affects, for example, DBP thresholds and responses. Funding has been mentioned, so this can be both funding for further development, and then there's some technologies that are already quite mature and that are only looking into further investment for expansion into global markets. Yeah, we also had other comments such as stiff competition, low consumer trust, and the last but not least, the legislation for application. Looking into the future for the Zero Pollution for Water cluster, so our 7 projects, so we do have similar challenges and different technological know-how, which is one of our strengths. We've seen now through this case study inventory that we have some case studies with similar problematics, in particular in Southern Europe, which is an opportunity to really complement the knowledge that we're generating within each individual project and draw on the conclusions of the cluster as a whole. And this could be compiled in a joint policy brief, as we've done previously. We're hoping to write such a policy brief at the end of most of our projects. And I think the collaboration, excuse me, so far has been quite successful. And this has also been recognized by other projects that have now sought to become a part of the cluster. So 5 projects, relevant projects, of course, to the Zero Pollution for Water objectives, will join us in 2025 to jointly create a higher impact. Finally, call to action for policymakers, researchers, and industry leaders. So I won't go into detail with that because we've heard a lot of it many times, I think, but it also makes the message very clear. So we need to improve the legislative environment, both with new legislation, but also with increased implementation of the already existing regulatory frameworks. I think one main pillar could be also recognizing our novel economic solutions, both treatment and monitoring. Today has been the focus more on monitoring, but treatment is another pillar. And yes, sort of recognize the potential for them to provide equal or complementary knowledge along with the existing solutions, of course. Finally, I think there's also, as mentioned, the need to have increased collaboration between researchers and industry. And this is always difficult. We all know this, but perhaps more incentives could work here. We've been mentioning we need the end users really to support us, and we need them to test our products. And as a last straw, again, here incentives might work to really get the ball rolling and make this happen. And with that, I'll end, and thank you very much.
Thank you so much, Heike. Thanks a lot for this comprehensive picture of the topics discussed and debated today, which opens, to say a lot of opportunities. And thanks, to the joint efforts of the 7 sister project of Zero Pollution for Water cluster, which is an unbelievable efforts, in order to not only to establish a dialogue within the project, but really to create the synergy and the strength of research and innovation to achieve zero pollution for water in the right direction. I really have nothing else, to add, because, a lot of things have been said, much beyond, the expectation. It has been really a bright and outstanding event today. And I guess that we can also go ahead, I mean, on our journey in order to disseminate what these projects and the upcoming projects also that will be new members of the ZeroPollution4Water cluster can do in order to achieve this goal. We are working, I mean, now, of course, I mean, with the new driver of the water resilience strategy. Also, we aligned also to the water resilience strategy to increase our capacity of having impact on the efforts for achieving a zero pollution situation for water. From Water Europe, of course, we are fully supporting all these initiatives, and we strongly believe that these projects have not only the potential but really have been able to give, I mean, the way forward on how to address a lot of challenges of the current situation of water in terms of pollution. So I really feel honored, I mean, of that we've been able to build and to create this event together to respond, I mean, to the EU Green Week 2025. That I really want, I mean, to thank for this opportunity, to having this opportunity for additional visibility, and because visibility also means that we can go, we can better secure, I mean, the outreach of the solution of the project to reach out to the market and for investment. So I would like really to thank you all, the speakers from the project, from the European Commission, and of course my colleagues as well. I would like to mention Ioana Oprizan, Serena Amico, and Anais Balada for having supported and these events with the organization and implementation. So once again, I mean, many thanks to all of you. The materials and documents that have been presented during this event, along with the questions and the Mentimeter outcomes, will be available soon, I mean, on the website of the ZeroPollution4Water cluster. As well, Europe, we also will ensure that this will be available through our channels. And once again, I mean, thank you so much for your contribution. Thank you so much for your insights. And see you next time pretty soon. We have, I mean, quite a few number of events next week, up to the end of June. So once again, many thanks and all the best for the rest of the day. Thank you so much.
Thank you very much. Bye.
Thank you. Bye bye.
Thank you. Thank you, Andrea.
Thanks.
Bye.
Bye,
Thank you.
Andrea.